All right, so for lecture 11, we're gonna look at sum and difference formulas. So basically we have some formulas that we're gonna use in order to solve some problems. So these formulas, we just have to memorize them. I mean, I know this is the first time I say this. You need to memorize these and have a system, so how to remember them. For sine of u plus v is sine of the first angle u plus cosine of the second v times cosine of v plus cosine of the first times sine of the second. And then sine of u minus v is sine u cosine v minus cosine u sine v. So basically these are similar. When you have plus in here. When you have minus, you have minus in here. Okay, for cosine of u plus v is cos u cos v minus sine u sine v. So if you notice, these signs flip in here. If you have cosine of u plus v, it's going to be cosine minus sine. And when you have cosine of minus, it's going to be cosine plus sine. And then these are the formulas for tangent. So these are things that you need to know. Memorize them. And then we'll basically just apply them and see how we can use these. All right, so for example, sine of 75 degrees. We know from the unit circle, we know what's the value of sine of 30, of 45, 60, 90, 135, but we don't know exactly how much is sine of 75 degrees. So if we were to do this without a calculator, the formula that would allow us to do this is, well, how am I going to think about this? I'm going to think about how can I write 75 as a sum or a difference of two known angles. What do I mean by that? Okay. Again, I'm going to repeat now. How can I write 75 as a sum of two known angles? What are the known angles? I know 30 degrees, 45 degrees, 60 degrees, 90 degrees, 135 degrees, and so on. So how can I get 75? How can I get 75? Well, I can get 75 by adding 30 and 45. So basically this is going to turn into 30 degrees plus 45 degrees. Okay, so I didn't do anything but writing 75 as 30 plus 45. Now I look at my formula, which is the formula that I'm going to use. It's the formula sine of u plus v. So I need to use sine of u plus v. And just look at the formula. This was sine of u cosine v. And this was the one that kept the sign, the plus. And then sine, cosine of u, sine of v. Okay, so if you remember this formula, then this problem is going to turn into my u now. This is my u is 30 degrees, and this is my v. Okay, so according to the formula, this turns into sine of u, which is 30 degrees, times cosine of v, which is 45 degrees, plus cosine of u, so cosine of 30 degrees, times sine of v, so sine of 45 degrees. And these are all values that you guys know from the unit circle. So sine of 30, that's 1/2. Cosine of 45 is square root of 2 over 2, plus cosine of 30, that's square root of 3 over 2, times sine of 45 root 2 over 2. So this is 1 times root 2 is root 2, 2 times 2 is 4, plus root 3 times root 2, that's root 6 over 4. So notice they have a common denominator of 4, so I can write this as square root of 2 plus square root of 6 over 4. Guys, so this is the value for sine of 75 degrees. This is the exact value of sine of 75 degrees. And this is the only way you would get the exact value, by applying this formula. If you put it in the calculator is just going to give you an approximate value. Okay, so the idea here, was to write the angle we are given in terms of angles that we already know, trig function values. All right, what if we're asked to do cosine of pi over 12? Okay, so now we're thinking in radians. So think about pi over 12. How can I write pi over 12 in terms of angles that I know? So it's kind of not as obvious to do it with radians. So one way to get these is to transform the radians into degrees. This is like first week of class. So pi over 12, to transform it into degrees, we multiply by 180 degrees over pi. And then the pi goes away. And then the answer is going to be 180 degrees over 12. And then this is 15 degrees. Okay, so now is that better now? Think about how can I write 15 in terms of angles I know? Well, these are the angles I know. 15, I can do it multiple ways, but usually the smaller the angles I use, the better it is for me. So I can write 15 as 45 minus 30. Okay, so write 15 degrees as 45 degrees minus 30 degrees. And now we have to go back to radians. So 45 degrees, remember that's pi over 4. And then 30 degrees, that's pi over 6. All right, so then cosine of pi over 12. I'm going to write pi over 12 as pi over 4, which is 45 degrees, minus pi over 6, which is 30 degrees. All right, so now according to the formula, let's look at the formula. What formula are we using? We're using cosine of u minus v, where u is pi over 4 and v is pi over 6. So if you look at cosine of u minus v, cosine of u minus v right here is cosine plus sine. Okay, so let's just write the formula so that we remember. Cosine of the first times cosine of the second plus sine of the first times sine of the second. All right, so now going back to our problem, cosine of pi over 4 minus pi over 6 is cosine of pi over 4 times cosine of pi over 6 plus sine of pi over 4 times sine of pi over 6. Now you get these values because you know by now, or you would go back to the unit circle. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2 plus sine of pi over 4 is square root of 2 over 2, and then sine of pi over 6 is 1/2. So this is square root of 6 plus square root of 2 over 4. Notice that this is the same as what we got in here, but that doesn't mean that we're always going to get the same answer. Okay, so let's see. What about tangent? Again, tangent of 15 degrees. I can write 15 degrees as tangent of 45 degrees minus 30. And then according to the formula for tangent, it is a little more complicated. So this is the one we're going to use. So it's going to be tangent of the first minus tangent of the second divided by 1 plus tangent of the first times tangent of the second. So let's write the formula. So we use tangent of u minus v equals tangent of the first minus tangent of the second over 1 plus tangent of the first times tangent of the second. So in my case, u is 45 and v is 30. So this is going to turn into tangent of 45 degrees minus tangent of 30 degrees, and then 1 plus tangent of 45 times tangent of 30. Okay. So tangent of 45 degrees, well, that's sine of 45 over cosine of 45. So I know that's square root of 2 over 2 over square root of 2 over 2. So tangent of 45 is 1. Minus tangent of 30 degrees. So on the side, tangent of 30 degrees is just going to be sine of 30 degrees over cosine of 30 degrees. I know sine of 30 degrees is 1/2, and cosine is square root of 3 over 2. So this is going to give you square root of 3 over 3. Over 1 plus tangent of 45, which is 1, times tangent of 30, which is square root of 3 over 3. So now I got to work this one out a little more. So I'm going to bring it to a common denominator. So this is going to be 3 minus root 3 everything over 3 over 3 plus root 3 over 3. The 3's are going to cancel. So what I'm going to get is 3 minus root 3 over 3 plus root 3. But I need to multiply by the conjugate. So the conjugate of the bottom is 3 plus root 3. And this is going to give me 9 minus 3 over, I'm sorry, the conjugate of the bottom is 3 minus root 3. So the conjugate of the bottom is 3 minus root 3. 3 minus root 3. So this is going to give me, when I calculate this using FOIL, this is going to give me 9 minus 3 root 3, and then minus 3 root 3. That's going to give minus 6 root 3, and then plus 3 over. This is going to give me, when I FOIL this is going to give me 3 squared, which is 9 minus 3. All right, so if we furthermore calculate this, 9 plus 3 is 12, minus 6 root 3 over 9 minus 3 is 6. And then I can, 12 divided by 6 is 2. I can distribute the common denominator. 12 divided by 6 is 2. And then 6 divided by 6 is 1. So all I have left is minus root 3. All right, so for tangent of 15 degrees, the idea was to write 15 as 45 minus 30 and get these values. I know what tangent of 45 is. I know these values. I can easily look at the unit circle and get the tangent as y over x, or think about tangent as being sine over cosine. Okay, so this is the exact value for tangent. All right, what about something like this? It says to find the exact value of this. So for these, it's kind of working backwards. So they're giving us sine times cosine, cosine times sine. So if you want, you can rewrite this as sine of u cosine of v plus cosine of u sine of v. So I'm saying that u is 20 degrees and v is 40. So now kind of match the formula. What formula has the right hand side sine u cosine v plus cosine u sine v? So let's look back at our formulas. So what formula has sine u cosine v plus cosine u sine v? It's this one, the first one, right? So according to this formula, the right hand side, this equals sine of u plus v. All right. So that means that this equals sine of u plus v, which gives me that my initial one equals sine of u is 20 and v is 40. So it equals to sine of, well, 20 degrees plus 40 degrees is 60 degrees. And now sine of 60 degrees is something that I know or remember, or if I don't remember, I go in the unit circle and get that that's what is that? Sine of pi over 3 square root of 3 over 2. And I'm done. So I hope you notice that this is working backwards. I'm given the right hand side of the formula, so I have to match it to the left side. The correct left side. All right, so the same for this. I'm giving my u is 73 and my v is 13. So let's see what formula has tangent of u minus tangent of v, 1 plus tangent. Well, we just did this one. So I know that this is tangent. This is this one, right? So this equals tangent of u minus v. But my u is 73 and my v is 13. So this equals tangent of 60 degrees. And tangent of 60 degrees is square root of 3. It's cosine of 60 over sine of 60 over cosine of 60. If you don't remember how to get it, look at the unit circle and that's how you're going to get it. All right.